Hello, friends. It's starting to become crunch time for the next version of .NET, which means we're getting a big review backlog, a lot of red issues, and assuming that you like watching these streams, more meetings for you to watch. Today we're on round 3, I think, of TensorT and supporting types, .NET Runtime 100924. We've finished in index and in range, and assuming that you guys aren't proposing changing what we already talked about, I think today we dig into tensor span of t.
Yep. Uh, as from last time, uh, we landed on the name should be tensor span. Um, for the most part, the shape of this matches the shape of span of t. Um, there are a couple differences specifically because this is over multidimensional types. Um, so uh, in the first review, we had discussed some of the general API, some of the shape of the API here, and one of the things that had come out was um, because this is multidimensional, you have the need to define a length per dimension. And the original proposal had given that the name lengths. There was some pushback against using the name lengths just because it was potentially confusing. System.array exposes it via named method get length. Um, Notably, that takes an index. Notably, that was done before we had the concept of spans and an allocation free way to get all lengths simultaneously. Um, Many other ecosystems use the term shape to define the lengths. If you were to talk about, for example, a matrix 3 by 3, its shape is that it is 3 by 3 dimensions. And so they correspondingly use the term shape to define the length of all dimensions and therefore the shape that the span is representing. The proposal has changed from lengths to shape. Uh, I don't personally have a strong preference on which we would do, but I don't think there's an alternative name really between those two. I think lengths or shape ends up being one of the two best options.
Don't all speak up at once.
I do think lengths might be a bit more intuitive, in that it's saying what it is, whereas shape, you kind of have to figure out what aspect of the quote quote shape of the data it's referring to. Um, a shape could, in theory, include something like offsets, just logically, or something that might have otherwise been part of strides. So I don't know. I think
The
lengths
other
might be
option is
better.
dimensions.
I think we determined that dimensions was confusing because it might be inferred to be number of dimensions, aka rank, instead.
Okay.
Yeah, but unless it's a param span, there's you can't pass a pointer comma 6 and
What do we call it on array? Like there's an array static method get lengths or something like that, right?
Yeah, it's get length and it returns just and it takes in an int and it only returns one.
Oh, we don't have one
Um,
that returns all of them.
yeah, we don't have one that returns all of them. It'd be nice if we did, especially since we've got an ability to do it in an allocation free way now with span. But it's just called get length today.
I guess my only concern with lengths, I do prefer lengths. My concern with it
Yeah,
is just then we would end up with a property called length and a property called lengths, and
right,
that might be confusing.
right. And then we had discussed previously, well, we could call length something like linear length instead. Um, but there that wasn't necessarily a clear win. And then the other aspect was when you're reading it in a method name. So void star pointer, comma, read only span init lengths, uh, read weird to some people in context of the other parameters. especially when you're considering things like the array version that needs to take a start index and lengths and strides, because the term lengths could be used to infer multiple different things at that point. I also preferred the name lengths. That's why I had used it as the initial name, just because I thought it was more intuitive overall. But just I had changed it to shape based after some of the feedback last pushback though, so I'm happy to change it back to lengths if that's what API review thinks is better.
I guess another benefit potentially of using shape over lengths is that if you are looking at like documentation for existing frameworks, right, to get an idea of how to do something, they'll all call it shape. And I'm not right. We're not trying to pull people to this framework from other frameworks, but if you're looking at like how to do something, you'd have to know to translate shape to lengths.
When it's used elsewhere, every other framework we're aware of, shape always means this concept.
Yeah.
And nothing else.
Yeah.
Yeah. There's one or two frameworks that define shape as the combination of lengths and strides, but most frameworks, especially the most prominent ones, use shape just to refer to the lengths.
Yeah, so TensorFlow, PyTorch, NumPy, which I think are the three big ones, all use shape in this manner.
For the property currently called length, is that the pointer diff between the zero pointer and the last thing reached by the last possible index?
Yeah, it's the so it's basically it's all the lengths multiplied together.
Oh, so it's not the amount of memory that's covered, it's the number of elements that you would hit in a for each.
It's the
Yes.
number.
Because I remember there's like take a 6x6 and then take a 3x3 slice out of it. The memory projection we'll talk about would cover dead elements, but the tensor will only have 9 reachable elements.
Right.
So that would be 9. You're saying.
Right.
Okay.
Yeah. Length is meant to be the length of all of the total number of elements you would iterate through, which is different from necessarily the backing range of allocation if it were a if it were a slice out of a larger tensor. No, Imo, it's not sum, it's product. Because a column is just one element, but a row is, for example, 1080 elements in a 1920 by 1080. So you end up multiplying. You end up saying if there's 1920 rows and there's 1080 columns, then you have to multiply the two.
It's
'cause-
probably more accurate. Oh, sorry, go for it, Jeremy.
I was gonna because if that's what length is, I know that span we called it length to more match array length instead of collection count, but I agree that length and lengths when they're talking about kind of different concepts is weird, but if we wanted lengths instead of shape, I think then length either gets a weird modifier or it changes the count.
Well, and internally we're also tracking the because we have the concept of the number of elements, right, which is length, but we also have the concept of how many elements are in the actual backing memory, because those may not actually match up, and we need that internally. So we also have that. So we basically have like an element count, a length of the actual memory, and then the shape/lengths. of that memory.
Because yeah, shape doesn't feel like a good name, but it doesn't feel like a bad name, and I don't know that I have a better one. I feel like
Yeah.
I saw some comments on the issue that people didn't like the change to shape, but may have
Yeah.
just been selection bias of the day that I was looking at the issue.
Yeah, there wasn't any feedback in favor of, but then of course there's the case of people who are happy with a change tend to not not to comment that they're happy. So it's hard to tell if people are actually unhappy with shape or if um, a few people were unhappy with shape and most people are now happier with it. But I don't have a preference either way. It sounds like Steven's leaning towards lengths. Lengths was my preferred name in the initial proposal, so I'm happy with it being lengths. We then would need to determine if length should instead be count or something like linear length. Um, maybe we could maybe we could clarify it more explicitly and call it enumerated length versus allocated length or something like that to differentiate between uh, what the underlying allocation size is versus how many elements you'll actually iterate uh,
Since
versus the number per dimension.
we also, since we have flatten, we also could call it something like flattened length.
Yeah. And so maybe disambiguating the flattened length there would be good.
Okay, so
The only other thought I had with shape versus lengths, right? I mean, I'm fine either way as well. When we were testing this with Nicholas, and it was originally lengths, he actually reached out to me and said, "I can't find how to get the shape of the tensor. What are we calling it here?" And so I'm the only, I guess, thing I'm worried about it if we call it something else is anybody coming from other frameworks is going to run into that same situation. I'm not saying that's necessarily a reason why we should do it that way, but it was something interesting that I noticed.
Yeah, I guess
I
it's
think that's a.
Go ahead, Dan.
I was just gonna say I think that's a case where we need to just have a doc explaining like here's concepts you may find in other languages or other ecosystems. Here's what they are in .NET. This is really a case where .NET is .NET, and we're going to have, while we may have a few people looking at docs from external ecosystems or coming from external ecosystems, ideally long term, we have our own docs that people look at. We have our own tutorials and examples people are looking at that are already doing the right thing, and we're accounting for the fact that .NET developers are familiar with .NET concepts, and so they're going to be familiar with things like length is the term used in array, it's the term used in span, so it's what they're going to look for here as well. They're not going to be familiar with shape themselves. And so I think it's a case where we need to cater first and foremost to .NET developers. And if we have people in the other camp that are looking at other samples, tutorials, or even coming from other languages, then that's what you're familiar with this, here's how you map it over here comes into play.
What were you going to say, Stephen?
It's not a big deal. I was just gonna say I'm totally on the fence, and I think we could go either way. Tensor itself is a term that someone who's only familiar with .NET and not, other things in the ecosystem aren't gonna really understand either. So the fact that this is all on something around tensors and the tensors namespace, and on one hand, kind of lends towards using terminology for core concepts that also show up elsewhere, and I think that's a feather in the cap of shape. But the flip side is, then you have span, and people are familiar with length, and length shows up on everywhere, and I think people are familiar with length from multidimensional arrays, which is the closest .NET concept, and so there it would make sense to use lengths. I think we're gonna succeed with one audience and lose with another audience, no matter which we choose. And given that, I would err on the side of doing the more .NET thing, but I don't think it really matters either way.
I guess maybe another feather in the cap of using lengths would be we do have the ability to expose something like get lengths on system.array. That would allow you to get all of the lengths in an allocation free way. If we were to expose that, would we want to deviate there and call it get shape to match here, or would we call it get lengths to match the existing get length method?
I assume we'd call it get lengths.
Yeah.
All right, so let's take it as a given for the moment that we're renaming shape to lengths. So I see there being head scratching between length and lengths. I'm not saying it's bad, just an area of concern. So do we want to rename length? And if the answer ends up being no, that may tell us that we want to switch back to shape.
I liked your suggestion of flattened length. Otherwise, maybe calling it enumerated length, or just calling it count. Because I think the other consideration comes down to, we know we want to expose the concept of here's how big the actual here's how big the number of items you would enumerate is. But then, like Michael said, internally we also need to track here's how big the actual underlying buffer is in the case you have something like a 3x3 sliced out of a 9x9, and that's unique due to being a multi-dimensional slice. So do we want to have something that exposes or allows for the eventual exposure of both what is functionally allocated length and enumerated length?
The allocated length, it keeps sounding useful. I just can't think of who would actually care. Like, if you were an OS,
Primarily-
you might care, so you can identify if some memory can be paged out. But we instead have OSs to do that for us.
Right, so it's primarily used as part of reshaping. But it's a dangerous reshape at that point because you don't know whether they're whether it's actually part of the total safe to access underlying view or whether it's effectively padding to the underlying allocation. A good example is that a 1920 by 1080 image may actually have its allocation larger than 1920 by 1080 pixels because the underlying graphics processor or other for other considerations may end up more optimally working with rows that are themselves aligned to a particular basis, in which case you'd functionally allocate a bigger image and then slice a 1920 by 1080 image out of that and expose it to the user. So it's an interesting case where a user might say, give me a 1920 by 1080 allocation as their root allocation, but the underlying allocation is actually larger than that for perf reasons.
In the other case we use it, though I don't know if this would be used by like end users at all, is when you're doing broadcasting, right? You can basically implicitly broadcast data without having to duplicate it, and so if you have like you're multiplying a row by like a single element, right? It'll essentially broadcast that single element, but it does it by essentially manipulating the strides and looping over that initial value. And so there, it's also important to know about that, but I don't know if the end users would need that as much as we just need it internally.
Yeah, and it might even, because it's dangerous, it might be something that we'd say would rather be on something like Memory Marshal or Tensors Marshal, to make it more explicit. This is a dangerous operation. Make sure you know what you're doing. And maybe at that point it doesn't matter what the name is here, because we'll never have them in the same API surface. It would only be as part of some hidden off extension method. I think I'd lean towards either length or flattened length if we think that just length might be too ambiguous for users. But length being the thing that Array uses, matches with that.
Yeah, since the top use that I can think of think of for it is knowing whether or not flatten 2 will succeed. Calling it flattened length makes sense, or flat length, but I don't know that we want flatten, so flattened. Total would also be fine, but
Yeah.
alright. So I've written the note changing length to flattened length. Popping back up again, your proposal actually starts with a should we have a constructor like this? So I assume you're asking the rest of API review, do we want you to add a constructor like this?
Right. So this was a note from the prior API review. You or Imo had mentioned basically the consideration of memcopy versus memcopy S, where the latter is more secure because it explicitly takes the length of the underlying allocation. We don't really you don't really need that concept necessarily for the regular span constructor, because all it takes is a pointer and a length, and so there's no computation there. You're assuming that the length is the length of the allocation or less than in all cases. Whereas for tensor span, you're taking strides, and so you could be taking a 3x3 slice out of a 9x9 allocation. In which case, having the length makes it a little bit safer and more explicit, because you're able to say, here's the pointer, here's the length of the allocation that pointer represents, and then here's the shape that I want to cut out of that allocation to track as my view. So it's really a question, should we have void pointer and then the lengths, or should we also pass in the flattened length of the pointer? Just capturing that API review note. I think that taking void pointer in and flattened length makes sense, and it does make it safer. It's an extra parameter, but it just forces that little bit of extra safety in this scenario. And of course, if a user doesn't want to care about it, they can just pass in init.maxValue.
I think that at least for the one that takes the stride parameter, we should have a length, because otherwise you have to do some funky math to figure out strides versus shape and whatnot. For the one that doesn't take the strides, I don't have a preference.
Well, I mean, pretend we inserted the parameter here with the constructor pairing feel mismatched to you?
That's why I had proposed both, because we tend to try and keep similar overloads, having matched up parameters. And while we don't always do that, we tend to squint a little bit when we don't line them up and question whether it makes sense, whether it could ever conflict or cause confusion in the future.
Yeah, because honestly, I th- I think if we had long span, we would just say we'll take span and long span, and we won't take one with a pointer, which means we were going to take a thing with a pointer and a length. So we can add the
Yeah.
length, and if people get annoyed, then we can pivot later.
Sounds good to me.
Is flattened length the real or the right name for that though?
I think given that we decided to call the property flattened length, I think that makes it very clear what it means.
I just mean with the second pointer or the second constructor. Can the combination of shapes and strides, like, are you limiting it for flattened length, or are you limiting it for backing length?
Maybe we could call it pointer length. Although that's a little bit potentially confusing.
That's 4, right? Oh, sorry, 8.
Yeah. Yeah, I don't have a strong preference there. Calling it flattened length could be confusing. Given length, it could be interpreted to be, here's what you want the flattened length to be, and then it errors if flattened length doesn't equal lengths multiplied out. Just calling it length is probably less confusing, but users still might mistake it the wrong way.
Slice length?
I think the biggest thing is people getting confused on associating the pointer and the length together. Maybe we could
What do we call it? Data.
I know
data
we say
length.
don't use tuples. Yeah. Data length. I was going to also say maybe we could force it to be collaborated by making it a tuple, even though we normally say don't use tuples. But I like data and data length more.
Then it tells you very specifically what length we're after. It's how far can that pointer reach.
Yeah.
I apologize. I had to step away for a second. Which length does this correspond to? This is the same as the public property.
No.
So then I think that's that. Yeah.
So that's why it's
So
now suggested as data and data
the
length.
property we renamed to flattened length.
But this is different than flattened length.
Right. In the case of
Yeah.
the second constructor.
It potentially could be in the case of the second constructor. Yes.
That this number is flattened length or bigger.
Right. Because the consideration here, which was brought up in the first API review, was that basically the consideration of memcopy versus memcopy_s, where memcopy just takes the destination, the source, and the number of bytes to copy, whereas memcopy_s takes in the destination length, source, and source length. And the latter is safer because it doesn't have an implication between the two pointers, and therefore you can be a bit safer. And the consideration here was that you're taking an underlying unsafe allocation, and you're creating a view over that allocation, potentially slicing out parts of it. and users could mess up getting the for example, they could have a 9x9 allocation and they could end up messing up the strides or the length such that it's larger than the actual underlying linear allocation length. So because this is a public constructor, even though it's an unsafe API, it is general goodness to make it safer for the user. And if users really don't care, they can just make data length max value. But it just makes the API a little bit more robust for users.
Sorry, data length is still referring to the number of T's rather than bytes, right?
Yes. At least that's my understanding, unless we want to do it the other way.
We could actually make it take T star instead of data, or instead of void star. The reason that we had it take void star for span was because that was prior to the language feature where any T could be a pointer. And now that we can actually have any T be a pointer, we just need to suppress it for the reference type case. We could make it a T star.
That feels better to me.
Yeah.
Okay. I'll copy that change up to the writable version. So then the next commented out block of things is how many array dimensionality constructors do we want?
Right. That was a question of, we have this one taking array. It has to do the type check to make sure that the array is actually a T. It needs to have considerations over dimensionality and other considerations. So should we have convenience ones that take 4 common overloads where the common dimensions are at least 2 and 3, and we could expose more in the future. But should we have ones that explicitly take T bracket comma close and T bracket comma comma close bracket?
What would the reason be?
Convenience for users and allowing them to have a safer constructor that works for the more common types and allows you to avoid additional checks for those common types. Otherwise, array has to do a bunch of additional checks that are costly.
Okay.
The one that takes system array, not the one that takes T bracket.
Yeah, not the SC array, but array.
Yeah.
Right, because I was gonna say all the higher dimensional things can be assigned to array. So this doesn't change color usability in any way. This is just a perf gain for those.
Right. And we could say we don't expose them now, we wait for user feedback. We could say we only expose it for 2 dimensions because that's the clear most common, and we could expand in the future as additional input happens. We know that there's cases up to 5 dimensions for use in ML and AI scenarios, but as you increase in dimensions, the chances users encounter them, and the cost of doing things with them increases. So the benefit of having increasingly higher dimensions diminishes.
And what's the cost of the constructor triplet in the generic type? Because basically what we're saying is it's a cost benefit trade off of that which is where maybe the 2 is common
Yep.
enough and worth it for how much it'll save versus how much memory it expands by having a tensor span of byte and a tensor span of int. That, well, you now would have been better just going through system.array.
Right. So there's a little bit of VM overhead in the case of the normal JIT usage. There's essentially no overhead in the case of the trimming scenario because it can all just be trimmed out. You can avoid the VM overhead by, instead of doing constructors, exposing individual generic methods called create on something like a static class called TensorSpan, or the static tensors class, or something like that. So there's a few options there depending on whether we wanted them to be constructors or create methods. But it's really only a cost if a user doesn't do trimming in this case. And then, in which case, there's a new VM method table entry for every generic instantiation, or in this case, 3 additional ones for every generic instantiation.
Okay, so do we want to just add the 2D and finger in the wind, say it's common enough, or just wait for people to complain? I guess, do you also have perf numbers? Do you know what you're actually talking here?
I don't have perf numbers off the top of my hand. It's basically the additional cost of it's the cost of 3 additional branches every time you want to create a tensor span from a multidimensional array.
Intel loves the really long pipelines, so branches are expensive. Or at least being wrong on a branch is expensive. Yeah, I'm fine with adding the 2.
It's going to kind of come down to the it's going to kind of come down to the same consideration with memory of T and recommending users cache the span, because the type checks you have to do up front to create the span end up adding up in hot loops. So you want to cache it outside the loop, reuse it in the loop, and pass it down as far as you can to avoid having to re-get it each time.
I would still say we wait till we hear from people about it, but that's just me.
Alright. I love less is more. I was just trying to be nice. Alright, for the middle, I guess they're the same, but for the middle constructor on theoretically multidimensional array, the start is the offset per dimension.
Yeah, it's basically you're basically saying what element you want the slice to start from. So if you had a 9x9 and you wanted to start at element 1 1, if you wanted your slice to start from 1 1, you'd pass in start of 1 1.
And then shape will then say 3 3, so now you know that you want 1 through 4 3 times.
Correct.
Which we keep picking
And
square
then,
things, which means nobody has to think about the dimensionality, but yeah.
And notably, I differentiated int start versus index start index because that looked to be how we were doing it in other places that explicitly took index in the BCL. For whatever reason, we opted to explicitly call that one start index when most of the time when index was used, from what I was seeing.
But where do we... Like, the closest constructor to this would be span, and it only has this one.
Yeah, there was various ones in memory extensions like as span takes it as start index, as memory, um, range was one that just called it start. It didn't have, but it also didn't have an overload that just took an int. Link, I believe, had one that took it as start index. There's also element at in link that takes it as just index.
Fair enough.
But the memory extensions as span ones are the ones that call start index. It looks, looking at it again, it looks like there's kind of a mix of them depending on what APIs you're looking at.
Okay. And the second one, presumably start and start index, should be starts and start indexes.
Potentially.
Well, because they'll pair with
it's
links.
It's a little bit weird because it's not necessarily the starts, it's the starting point. So it's not like each dimension gets its own start. It's rather that, like, if you said row 2 column 1, it's not that you're starting that represents a single starting point in
Gotcha.
the dimensional space.
Right. Okay.
Which is a little bit weird to think about.
So that is how you compute that value.
Yes.
So you turn the
Yes.
array into the pointer representing the starting element, the thing that will be zeros all the way, and then the rest of it is bounds off of that. Okay, sure, start's fine. I returned to my comment from the first time I saw this and said I don't know that I'm smart enough to use this.
Then we've got the standard empty property, the is empty, the static empty property, the is empty instance property. Length, we have rank, which is the number of dimensions and matches the name used in array. We then renamed shape to lengths, and then we have strides, which represents the distance between each element for at a given dimension. So typically at least one of the strides will be 1. That isn't necessarily always the last one. In the case that you've, for example, transposed a view without allocating. So if you went from row major to column major, you can do that in an allocation-free way by just swapping the row and column strides, for example. And that's used for various reasons in performance in different contexts. So strides and lengths will always have a length themselves of rank.
Right. So if strides is not progressing from low to high, then things that will look like they're adjacent memory may actually be very expensive memory fetches that are really far away, right?
It's not just if they're
correct.
progressing from low to high, it's if the final dimension is 1 or not. Because you could have intermediate dimensions that aren't necessarily low to high,
Right. But
and they can still be
Right,
next to
but
each other.
if you flip from row major to column major, something that looked like it was oh, and now I'm doing a linear walk over like 5 pieces. It's like, well, each one of those is actually a page fetch, so hold on.
Right.
Yep.
Just the problem
so,
of big
so
memory.
if
So.
strides is sorted, yeah. So if strides is sorted, then you have at least you typically have some kind of contiguous memory that you're iterating. If they're not sorted, then you're potentially doing what is seemingly random memory access to look up elements.
Fun times. Just making sure I understood the consequences.
Yep. We then have indexers. We've got the one that takes the init indices. Unlike regular span, which has the language hookup to implicitly convert, to implicitly allow using indexing where it resolves against length and other bits. The language asked that we explicitly expose ones that take in index here.
According to the table of word usage of .NET, indices is a banned word.
Oh, that's terrible. But okay.
I'm just saying.
I would not have expected that.
This is in the book that a long
Why-
time
why-
ago,
Why did we do that in the book?
because I guess early framework was inconsistent, and Christoph said, "We're gonna have one answer, damn it," and we picked one. It predates me, so
Okay.
I'm just.
Okay.
I was
think
just
we
looking
picked
at
the
it. I'm
wrong
like,
one, but
I don't remember
for
which one we picked,
consistency.
but I know that this is written down. So, all right, continue. Sorry.
Yeah. So the language asks that we explicitly expose ones that take in index. That way they don't have to do the same magic light up here. It would be very complex for them to do. So we are explicitly taking both inint and in index as the types. There is then a third one, which returns a tensor span and which represents the slice syntax for the same reason, which takes in params of ranges. The set method then exists, like was discussed in the first review, because there's a common desire to allow what is effectively copy to via slicing. That's very prevalent in other languages that support multidimensional slicing. And so if you did this slice equals some other span, it is effectively equivalent doing some other span dot copy to first collection slice.
And then return other span.
So I'll type.
Because setters have a return that nobody pays attention
Oh,
to.
it's a. No, setters don't have a return. They're void.
Setters have a return. They return the input argument cast to the output type.
No, they do not. NIL, they are void.
In C#, they return the input. That's why you can do A.B equals C.D equal 5. Because the setters will return the value.
Right, but that's just.
Index setters may be
a-
different, but
that's
property
a,
setters definitely have a return.
Nope. That's a purely language concept where the language just implements it as a separate get and set call. The actual set
Okay.
call itself is void returning.
Fair enough. I guess I learned something today.
It doesn't really matter for C# users, but when it comes to how other languages may view it, it does matter that the set is void returning.
Okay. My understanding of the language these days is one of these two is redundant, right? Either the square
So
bracket will call
it's
slice, or slice will
redundant-
project the square bracket syntax. One of the two.
It's redundant for regular span because the language for single dimensional slicing and indexing has this magic rule where it says if it defines a slice method and a property and a length or count property that returns int,
Okay.
then it allows the slice to work.
The and is what
The
I was
language
missing, yeah.
doesn't want to have to add that for, yeah, the language does not want to have to support that for multidimensional arrays, so we need to expose it explicitly ourselves.
Fair enough. Yeah, I mean the set on this feels wrong, but I
Yeah,
get it. And if I was thinking of the line of code of like
wrong.
x of 1 to 3 equals y of 2 to 4, and you're like, I guess I understand what that's doing. It feels weird.
Yeah, it feels weird at first, but it very much is prevalent in almost all languages that have broad multidimensional slicing and indexing support. It's a fairly common and standard operator, and it somewhat makes sense if you want to think about the fact that when you're slicing, that indexing is just slicing where you're reducing the dimensionality, and therefore if you're doing this 0, you're actually slicing to a scalar, so you're removing one dimension from the lengths, and you're producing a t. So it's conceptually the same thing in practice. It's just really hard to think about in the first place, because people don't like thinking about multidimensional access.
Fair enough.
We then have the standard equality comparisons, comparison operators. Those work just like span. They compare the biref, the shape, and the stride. They do not perform element-wise comparisons because that's unexpected for C# users, which we've discussed many times in the past. I had proposed previously that we have relational operators like this for the vector types return the vector types themselves, because that's what's convenient for many users who are doing vector and tensor-like operations. But the argument at that time had been .NET developers expect if x equals y to work and not fail, as well as many other considerations around how people typically expect operator equals to work, like equals and IEquatable and other things. It was brought up, it was asked that we bring up again whether or not we should do that, but the proposal here defaulted to matching what past API review decisions had been made.
Seems like a lot of crickets.
I mean, my opinion is it would be better to have it return the tensor span, as Tanner was mentioning. Again, that's consistent with existing tensor frameworks, and I get specifically this is a span on top of the tensor itself. It's not the tensor, not the tensor itself, but more of like a view of the tensor. But it would still be consistent in that regard, so that would be my personal vote. But I also understand that it is, completely not in .NET conventions for that.
It'd be nice if C# had the ability for for relational operators in particular to be overloaded by return type, and if it could target type the use of bool versus tensor span of t, and then we could expose both. But language does not have that.
And it would gloriously be another place that you weren't allowed to say var. Um, yeah, I mean the trouble is I see both sides, and it to me the tiebreaker then comes down to consistency. Of there's I believe nowhere in the BCL that equal equal returns something other than a bool. And once equal equal is not going to return
Yeah. And the
the
one
thing,
other
it feels weird that less than would.
and the one other place where it would be where it would have made perfect sense to do, and where it would have even not had any of the arguments against it, like, well, what about performance, from having to do element-wise comparisons, which would have been the system runtime intrinsics vector types, we said no on. So
Right, so I think it sounds like we're leaving it like this. And then everybody's favorite thing to abuse in the language, conversion operators.
So there's an explicit conversion from system.array because system.array has to do the type check to make sure it's actually a T. But there's an implicit conversion from the single dimensional SZ array, since that one is typed and can be known to be safe. Matching effectively what span has there. And then there's an implicit conversion to tensor span of T. There was the question of whether we should have implicit conversions from the multi-dimensional arrays, but given we decided not to expose the constructors at this time, I would assume we're also opting to not expose such implicit conversions at this time.
I mean, do we need the explicit conversion from system.array? Like, why not just let people just say new?
Lots of people don't like writing new.
Yeah, I mean, as an explicit conversion, it doesn't mess with things like where we get hyper implicit language rules combining poorly with user defined conversions, but I don't know. And my personal stake is every time we add a conversion operator, I feel like we made a mistake. But nobody else is complaining, so I guess we get what's on screen.
We then have the standard, except for one of them, or except for two of them, the same APIs that are exposed on span and read-only, that are exposed on span. Not all of them are on read-only span. So we've got clear, copy to, fill. The new one is flatten to, get enumerator, get pinnable reference. We have slice, and we've got the pair of slices specifically to match the language ask that we don't have that they don't have to add their own support for these. Try copy to and try flatten to. For slice, the interesting thing is that span slice, of course, has a version that takes a start and a length. Of course, you can't really represent that as multidimensional unless you have an overload that takes both params read-only span inint for start and params read-only span inint for length, and that becomes kind of unwieldy to represent because you're no longer having an optimization of, oh, I'm just passing down two parameters. You're still passing many parameters, and now you're disconnecting the associated start and length that represent the range. So I opted not to suggest that one, and users can just use the range overload for that.
Makes sense.
We then, as with regular span, we obsolete equals and get hash code.
Okay. For copy 2 and flatten 2, copy 2 requires the same shape and flatten 2 does not.
Correct. And I actually think flatten 2 was meant to be a regular span.
Was it
not
was it a
tensor
regular
based
span or
on
was
what
it
we
an array?
discussed.
I think this one would be
I think
span.
it was. I think it was just span.
Yeah. Okay. Because
Yeah.
I was thinking we had that flatten was
And-
supposed to go into straight linear memory, so it was supposed to be span. And that's why we have the flat length. It tells you
Right.
how long your span needs to be to flatten into it. Okay. So those just got
And
typoed
we
somewhere.
don't. Yeah, we don't need the version that takes array because this is a ref struct, so every language that has access to this type is also going to have access to span, and therefore the ability to create a span from an array. Even F-sharp's looking at getting implicit conversions for array to span in a few cases, so we shouldn't need to expose both the array and the span overload like we do in most APIs.
Okay, and then struct enumerator whose link dot count, if link was allowed to be invoked on it, would return flattened length.
Yes.
Yeah. Chat points out our obsolete equals and get hash code should also EB never, so I'll just note that down.
Did we do EB never on span?
That's what Kevin says. And now if he's wrong,
Oh yes, we
the
did.
whole world will know it.
No, I was just wrong in copying the attributes over.
All right, and I think last time we talked about reshaping type things, and I think your answer is those are delayed. Like they'll come
In a-
later.
Yeah, those are in a later review. Yeah, because we've we've been taking some time to get through the reviews so far, so we didn't think that we would be able to get them, and getting the core shape approved was more important for this initial.
Yep. Just thinking through is the proposal complete, and the answer is no, intentionally. So.
We then have read-only tensor span,
I have a silly
Um,
question.
which
Oh, wait.
mirror span but remove.
Never mind.
Yeah.
I was gonna ask, how would we be able to have a tensor of like int star? And the answer is pointers can't. Wait, can pointers be used as generic parameters?
Not today. You kind of have to define your own wrapper type called pointer of t that contains a t star.
Okay, because I was just thinking through get pinnable reference and what happens if t is itself a pointer. But, apparently can't be. So never mind. Moving on. Read only tensor span.
Yeah, when it is eventually supported, we'd just be returning a ref t pointer, because even though you have a pointer, the array of pointers may not itself be pinned, and what you're getting is a pinnable reference to the array. So
Yep.
yeah.
All right.
Yeah,
So,
so then we've got read-only tensor span, which mirrors tensor span, and I've updated already based on our earlier in the review points like data and data lengths instead of shape, using indexes instead of indices. Uh,
well, this should just have been
Forgot to
index
update
in
it to flattened length though.
oh, yeah, I guess missed that. Yeah. Also, by the way, it's kind of jarring if you edit it while we're talking about it. So, if you can, you know, not, that'd be great.
Sorry.
The so span tensor span, you included a span constructor, but you don't have a read-only span when in read-only span. Is that intentional or is that just an omission?
Yeah, no, that was an omission.
Okay.
That was an accidental omission.
So I'll just copy that in. Okay, questions have been answered, so now we get the middle body, which should just be the other thing, but with right things removed, right?
Right. And length should have been flattened length, notably.
Uh, right, again,
For the main property group.
right, the copy that I have over here that I'm updating already got that, so that's where
Okay.
when you update
Yeah,
things
so
and I
it's
update
just
things,
with
it gets
the-
weird because
the-
I can't find where it is anymore.
Yeah. So the core API instance method list is the same as span, but with clear and fill removed, since those ones are mutating.
And all right, looks like some other bad edits happened because you want read-only tensor span copy to go to a tensor span, right?
Yes.
And then flatten to goes to a span.
that one. Yes.
Yeah. And then this set should not be here because that implies write access, or that's the copy semantics, but we're not copying.
Yeah. Correct.
The conversion operators have a different shape. Oh, because the one that's missing is the writable can go to the readable, but we don't want the other direction intentionally. Okay, and then a thing that we skipped, assuming it was written up here, is do we want a to array?
Yeah. And specifically, there's the do we want to array? Do we want to call it two flat? Do we want both two array and one potentially called two flatten? Do we want just two array? Do we want to skip both of them because they're a little bit confusing in how they could behave and perform, and they allocate, and users who really want it could just do copy to after allocating the correct size. I don't really have a preference here. It's a convenience method that that users could have.
Yeah, I think that people, since it's enumerable, people may think that to array is like an enumerable thing, and it's going to give them the flattened, compact structure. Um, since it's a multi-dimensional thing, they could expect it's going to give them the multi-dimensional thing. Um, so yeah, I think leave it off. If somebody wants to
And if
make an array, they can make an array and then call copy2 to fill it. And if they want to make a linear array, they can make a linear array and call flatten2 to fill it. So
yeah, and there's always the option to expose extension methods if people want to have one called toArray and all that. So we can always also add it in the future.
yep. Okay, so I think with that we've completed TensorSpan and read-only TensorSpan. Are we moving into the bigger types?
Yeah, now we're going to the actual tensor types. So whereas TensorSpan and read-only TensorSpan were the slices of the larger ones, we actually need the concrete backing type that contains the original allocation. But we also have the consideration that 50 different tensor libraries out there for .NET. Many of them have defined their own tensor types, and while all tensors tend to have a similar API set of APIs, they do. We obviously want to be able to allow users to say that their types are tensors themselves too, so that they can represent that data more easily. And so we've got the interfaces, iRead-only tensor and iTensor, which follow the general generic math setup of taking a T self and a T. And then the split is based on whether it's usable for writable stuff or not, and kind of mirrors the structure of iRead-only list versus iList. So you've got on iRead-only tensor, you've got properties like empty, is empty, length, rank. You've got an is_pend property, which we had in our first review we had discussed that was desirable to simulate kind of what memory of T had there, for knowing if the underlying allocation was actually pinned in the case that it is backed by native memory. You have the indexers. They return a T instead of a ref T, because the language does not allow interfaces to effectively state things like this is an unscoped ref. That's only allowed on struct types today, and so you can't really correctly annotate that the ref T returned could be a direct member, such as an inline array element. For a struct, you can't annotate necessarily that it's not otherwise captured in other scenarios. So we're just returning returning it by value directly, much as list of T does, which also avoids lifetime and ownership issues with the interface contract here. That may not be representable by all types that would implement the interface. We then have methods that allow you to get a read-only tensor span from the tensor, and therefore allowing you to work with it in the sliced view, which can be done safely. We've got the copy2 and flatten2. Flatten2 should have been span though. And then rather than having a property for lengths and strides, we have the same general consideration of interfaces, depending on scenario, may not be able to correctly implement it in the case, for example, you've optimized small dimensions to be inline arrays. So we explicitly have them be methods that allow filling the span instead. That way it's safe for the interface. And then the rest of the methods for the read-only are straightforward and just mirrors of what's on the span type there. It's also notably intentional that these aren't implementing the operators. People have uses of tensors where T is potentially any type of object or string. So you don't want to restrict it saying that it can only be numeric types. That would cut out, for example, bool. Instead, the way that the support for arithmetic and other operators is going to work is the language is working on adding extension operators as part of their general extension everything feature, at which point we'll be able to define in the static tensor class something that looks like extension operator plus over iRead-only tensor T self T, where T is I addition operators. And then you will be able to do operator plus on anything that takes a read-only tensor of T, where T supports addition. So it's a way we can expose that functionality in the future, ideally the .NET 10 timeframe, without restricting the actual interface itself.
Fair enough. So as read-only tensor span in index, you called it start index singular, and in slice you called it start indexes plural. Do you want it singular or plural?
Singular. The calling it plural was just it's from when I had the same consideration as you were asking of should this have been starts and start indices, and then as working through it and talking to people, it came to calling it starts was confusing because it's not representing multiple starts, it's representing the singular starting point in a multidimensional piece of data.
Okay.
And I just missed updating it in that place.
Okay, so is that, to scroll way back up here, does that also apply to, that doesn't apply to the indexer, because the indexer, you are specifying an index per dimension. So this one is correct as plural. Okay, because you're not specifying,
Yes.
you are specifying a point, but you're specifying multiple indexes. But then this slice, and yeah, the slices here
Yeah, I think that's the
Are
same
singular
consideration. You're still
plural?
representing
Yeah. Okay. I'm probably caring too
Yeah.
much. Nobody's gonna look at these names. What I cared though was that this was that these didn't match.
Yeah.
And then that means the ranges should also just be range. Or is it?
Yes.
So this is plural, this is
No.
singular, and this is singular. Okay. Okay. Language is hard.
Language is hard. It's why English is like the only language to have a spelling bee.
Word sports. Okay. And then try flatten 2 is span. Alright, and so while the interface couldn't / shouldn't say ref here on the indexer, get pinnable reference, we're still okay and happy with putting on the interface? That all I read-only tensors can be
Yeah,
pinned?
because you should still be able to. Yeah, that you should be able to pin them, and you don't have any potential lifetime issues because that API is only meant to be used with pinning scenarios. And so it explicitly scopes the lifetime of the ref that's returned. The weird consideration for returning refs tends to happen when you're returning a ref and also taking in a ref, and that's why as read-only tensor span has to mark the input as scoped, because otherwise it could be implied that the start you pass in could be captured by the thing, by the method itself, potentially on the this.
Yep.
And then could potentially be returned as part of the new ref you're returning, which then messes with lifetimes more.
Yep, and then are the scoped parameters required in the interface, since an interface can't itself capture? Or is it required because it's returning another span?
Yes, because it.
Right,
so
because
it's-
this scope says
uh,
this
I don't.
is
I-
not captured here. I think, right?
No, I think in the default span rules you don't need scoped on the interface, but the consideration is that the language is opening up the ability for generic parameters to be ref types, and for ref structs to be able to implement some types of interfaces. In which case, someone might have a ref struct that could implement the iRead-only tensor, and you want to say that this is scoped and therefore can never be captured.
Okay.
But you still want,
by this.
even without that, you still want scoped here because we want to say that it's not captured and returned as part of the read-only tensor span.
Maybe I thought the default language rules were that this is where Jared needs to show up and tell us that where we're suddenly getting it wrong and point to his 200-page doc on it.
Yeah.
I thought the default language rules were that the return had the same scoping as the input by default, and so that was already fine. The issue is only when the input can potentially live longer than the method scope, than the call, and escape past the original lifetime. Which it wouldn't in the default return case, because it would have been presumed that the return value has the same scoping as the input parameters. And so there wouldn't have been an issue.
Asked and answered. Can we delete the word scoped? No.
we I don't believe that's exactly right, Tanner. Because like if you try to implement this, if you just have as read-only tensor span, if you just had to try to return a span argument, it will fail if you have scoped. Like, I can try quickly and sharp left.
I thought that the language changed the defaults when they introduced the scoped keyword, and the defaults differed between whether it was in a ref struct or on a regular type.
Yeah, I'll just let Steve do it.
I put it in chat.
Right. I know scoped blocks that case, but what I was saying is that by default, it's not technically needed because the default rules would have said that the span could have had the same lifetime as the return span could have been the same as the input span. And so by default, the language ties those lifetimes together. Scope
Right, but
just
this
means
isn't- this
that
isn't
this
about
one is definitively not tied to that one.
Right, but this isn't necessarily about lifetime. This is telling a consumer, don't worry, your span won't be captured because it can't be. So even if the lifetimes
Right,
are the
and
same,
also won't be returned.
exactly. Right, whether or not they have the same lifetime, I still want to know. It's still nice to know that my input won't be used by the output.
Yeah.
Okay. Yeah, I had incorrectly answered a question somebody asked in chat of why we had this param scoped previously, and I'm like, oh, because tensor span is itself a ref struct and the rules are different. But I guess it has scoped because it's returning a ref struct, and also because it's itself a ref struct.
Yeah.
All right. Okay, so we covered
We then have
the ref, and so I think we're now to the writable interface.
and so for this one, the reason that the create APIs are on this one and not on the other one, and not on iRead only, is because it's not useful to have an API that just creates iRead only memory that you then can't mutate. It would need to, if we had something on regular tensor, it would need to be like create and fill. So the create methods are just here. We've got one that takes the lengths, and we've got a member that allows you to say whether the memory is pinned or not. We could choose to not expose the pinned property, but it should. If you're allocating native memory, the memory can always be pinned. If you're allocating managed memory, you can use GC allocate array pinned, and you'll still get zeroed memory that is pinned and therefore movable. So it's beneficial when you're working with large data to be able to say, don't move my long-term memory. So defaultable pinned property. The overload that takes lengths and strides is for the case, like I mentioned earlier, where you might have a 1920 by 1080 allocation, but you might want the dimensions to be aligned on a different consideration. So you might want a 1920 by 1080 that's where each row is aligned to a, let's say, a 4 kilobyte window. Either for tiling or chunking or other purposes, and so the overload that takes both lengths and strides allows for that consideration, where you've got a larger allocation with a smaller view from that allocation. And then create uninitialized is just like with GC allocate array uninitialized. It allows you to get memory that isn't definitively zeroed in the case where you're doing a variable allocation and you know you're immediately going to be filling it with other data. We then have the is read only property.
Where are we
like,
looking right now?
Oh, go ahead.
Where are we looking right now?
On iTensor T self T.
But you were talking about
Middle of the
alignment.
screen?
I'm not seeing anything to do with alignment. Can you?
I
Or
think
did
that
I
was
misunderstand?
the when you want links and strides
Right,
instead of
it's
just
just-
links.
Oh, I see.
Right.
It wasn't
the
about
consideration
alignment.
is
of
that
the- it wasn't about
that
alignment
there.
of data and memory, right? That's what I was not understanding. I thought this was going along with pin when you were saying you might want it to be aligned to a certain location in memory.
No, sorry. I should have clarified. I was trying to give an example of where there's cases where you might end up wanting to have rows themselves not appear immediately after the next column. One of those cases happens to do with alignment, but there's other scenarios where that equally applies. For performance considerations, where you may want to say the rows start more distance apart for other purposes, like padding, for example, which is related to but not the same as alignment. So, for example, you might want to say that every row is a multiple, every underlying row is a multiple of 32 bytes, so that you know that it's safe to use, for example, vector 4s on the data, and part of it's not going to be used, but that the actual visible part of the row might only be a multiple of 24 bytes instead. It's used, for example, when you're doing you might have a vector 3, and therefore you're accessing 96 bits at a time, but you want to ensure that that you can safely access 128 bits without it going into the next row.
I'm still wondering about the is pinned here. That seems like, I don't know, does that need to be pushed down into every iTensor implementation rather than it just being some factory method that allowed you to produce one that was, pinned if you absolutely needed it to be? It seems like an interesting concern to push down into one that might be backed by something that's not on the GC heap, or to force anyone that implementation that was on the GC heap to pin it.
If it's not on the GC heap, it's presumably already pinned.
Right, but that's part of what I mean. Then this argument is meaningless.
Well, you're saying, do you want this to be definitively pinned? And so it's just like GC allocate array, where true means I am pinned, and false means I can't assume that you're pinned, but you may actually be pinned.
Sure, but my point is,
it doesn't mean that it can't be pinned.
I understand that. I'm saying for an implementation that's based in native memory, this argument is useless. And for an implementation that is based on the GC heap, it feels like an interesting concern to push into the constructor, when I would imagine we could just have a static factory somewhere that created a tensor implementation backed by pinned memory, create pinned or something, rather than having it be part of the interface. I guess I'm wondering why it needs to be part of every iTensor implementation rather than just one of the multitude of built-in implementations that we provide.
Well, the consideration is that if you've got a scenario where you're wanting to work with the concrete tensor type, without having to necessarily be working with a span. So let's say you want to be able to store an iTensor somewhere, then so it just like you sometimes need to store a memory, and because you can't store the span, then you may have a scenario where you want to say, I need this memory to be pinned because I know it's going to be long-lived. I need to be able to rely on alignment in other scenarios. If it is backed by native memory, the pinned input is always treated as true, because the memory is always going to be true, and the is pinned property will return true, saying, yes, I'm definitively pinned. And so you can treat me as if I'm always pinned. While for the GC backed, it allows the user to say, hey, I'm working with big data. I really need this memory to be pinned because it's going to be long-lived, and I need to be able to rely on it not being moved around in memory, and things like that. And so it gives the users the power to say, regardless of whether it's backed by native memory or another memory, I can rely on the fact that I can say I need this to be pinned.
Right. I understand the benefits of being able to create one that is pinned, that is definitively pinned. I'm questioning why it needs to be part of the interface. Why can't it be a tensor create pinned, for example. The static class tensor
Because
dot create pinned.
because that forces you to work with it forces you to have a tensor of T which uses R allocation semantics rather than say allowing TensorFlow to use its own allocation semantics and create a TensorFlow tensor of T that is pinned.
But that TensorFlow tensor of T is going to be native memory. So it is pinned.
Potentially, it could also choose to use its own pool, or it could choose to use GC memory for some sizes, things like that. So it's basically a question of, do we want users who are saying, I want to write a method that works generically with tensors, where the caller gets to say what the tensor type is, or do I want to force them to always use R tensor of T when allocating pinned memory that they know is definitively pinned?
Yeah, I mean, like, I agree with Steve definitely in asking the question of, when someone's doing it generically, is it going to matter? Because anybody can put an overload of create that has pinned on their own type. You know, whether you call it a static create or you call it a constructor or whatever, you can do a thing on your own types. This is when you're calling it from a generic context.
Right, and there's considerations of, like, maybe you're writing it generically, and the difference of having a tensor pinned and actually having a T self produced by the create that's pinned is the difference of whether it's in CPU memory or GPU memory, and the difference of whether you need to do an extra copy of potentially megabytes or gigabytes of memory. It may be the difference of actually needing to do an allocation of that much memory versus reusing an existing pooled buffer that you know is no longer in use, but that you've kept in your own internal memory pool. There's a lot of considerations where a T self create can do an optimization for the allocation it's returning that may not apply if we only allow users to say tensor.create is the only way to get definitively pinned memory.
I don't know if we've used a default parameter on anything for interfaces in generic math already, but we did in FDG3 say do not put default parameters on interface methods. For what it's worth.
It's one of those things where if we don't do it in V1, we can't do it later.
I'm just saying we
could
wrote this
have a
at
different
a do
one
not.
called, yeah.
So
Right, and the consideration there is, like it calls out specifically, because there may be an interface that does not want it to be defaultable. This happens to be a case where, like cancellation token, there's no potential ambiguity for implementers on what it means.
right.
Um,
If everybody's
we could
implementing
have
create
other
explicitly,
overloads.
well, for one, if you're implementing explicitly, your overload's not callable, or so you shouldn't define it here. You'd get it from the interface. But if tensor of T implicitly defined create, then the confusion comes from when tensor of T says the default is true, but the interface says the default is false, and that's why we said just don't do it.
Right.
I mean, this may be scoped enough that
But
we care, or maybe we don't.
if we don't have some way of creating pinned memory in V1, then we can't ever expose that in the future in a generic fashion. That's not something you can dim. If we didn't want default parameters, we could have two other overload groups of create pinned and create uninitialized pinned, or we could have create pinned, take a bool is uninitialized parameter if we just wanted 3 groups. I think this is a case where there's no potential for confusion. A derived implementation wouldn't even need to do pinned equals true, because pinned equals false doesn't mean can't be pinned. It means may not be pinned, or is allowed to not be pinned, rather.
Thoughts, Steve?
Um, I think I'd err on the side of having the optional parameters, just because I agree it's probably not a real source of confusion, and statics are static methods on interfaces, or static virtuals on interface, are different than instance and how they're usable and consumable. So it's, you don't really run into the situation as much where you're past an instance typed as one thing versus something else, and you call a method on it and you might get a different default value based on whether it was from the interface or the concrete implementation.
Right.
So I think I think what's shown is fine, I guess. It just feels like a lot of, I don't know. I guess it's fine.
Okay.
I definitely understand the considerations of like forcing this down onto everyone, but it's also one of those cases where this is an important aspect of working with big memory, and I wasn't able to come up with a design that allowed you to have similar functionality in a better way. It kind of gets to the concept of, if you really wanted to do this, like the maybe a better way would, you kind of get into the C++ template allocator-ism, where everything takes a T allocator indicating how memory gets allocated, and that's not really a good usable pattern.
If we're going with defaultable stuff, could strides be defaulted to? Like, would that be? Would it work to basically say if strides.length is 0, then it's as if it wasn't provided? Would that be helpful in any way, or is that just confusing? I'm wondering, like, again, 4 different implementations versus 2 different implementations. Could we consolidate?
Yeah, I guess you could do it like that. And you could say that it makes sense. I thought that it was potentially that it could cause confusion, and it seemed to be kind of along the realm of it seemed to be more pushing along the realm of something that we normally don't allow for an API shape, but I don't have a strong preference there. I agree, we could just say that if strides is empty, then treat it as if we need to compute it ourselves.
What would you expect an implementation to do? Like, presumably an implementation isn't going to have 2 complete different implementations of create, right? So it would the shorter implementation delegate to the longer one, or would they both delegate to some shared implementation? And do you have a sense of what that looks like?
Yeah, my guess is that you'd have create, which would compute the strides, and then it would defer to a shared internal implementation that assumes the arguments have already been validated, whereas create that takes strides would validate lengths and strides are correct and then call that internal implementation.
I see. So if you did have them as one, you would you basically just say if strides.length equals 0, then compute, else validate, and then continue using it.
So do we want to do that?
Oh, I was suggesting if we wanted to do it, just have line 233 and not line 232.
Okay. I mean, our usability guidelines for defaults say once you have 2 or more, then create an overload that doesn't have the defaults. We can say this is a power thing or a different scenario, and that's why I gave this one the dim of you don't need to touch it. We're syntaxing this for you.
I don't know. It's probably 6 of one, half dozen of another at this point. If I would go with whatever Tanner preferred, or Michael.
I feel like in this case, if we're going to end up saying that we need to have a second overload, anyways, then just having pinned equals false be optional on the first works. It's the same thing, and it's.
Well, I mean, there is a difference, and one of them is this is syntactic sugar declared on the interface, and the other one is that somebody has to implement 2 methods.
Well, our guidance is that users should always re-implement DIMs anyways, because DIMs are really just there for binary compat, and they're terrible for perf and usability.
Fair enough.
Like, if you don't redeclare the DIM yourself, then you can't actually access the DIM outside of a generic context, and if you don't re-implement the DIM and it's on a struct, then it's going to box and other problems. So we basically tell users re-implement DIMs anyways.
Fair enough.
Well, I don't think we'd want to pass in default there for that line 232 if we did it that way anyways. Right, we'd still want to provide a bool pinned false versus true because you may want it pinned without specifying the strides.
Right, but then you just say lengths, comma, pinned, colon, true.
Well,
I guess that's true, yeah.
Yeah.
That would enable the scenario, and but all right, so we'll just leave it at that, I guess.
I mean, I'd be fine with just having the 233, but I'm fine either way.
Yeah, I don't have a strong preference between if it's just 232 where both parameters are defaulted, or if we had the previous where we've got both with pinned false and one without the strides default. My consideration was just that if we're going to define a second overload anyways that just takes lengths and defers down to the other one, then I think this pair of 2 ends up being easier for users to use and understand than the other pair.
I need to see my off by 1 error to see if it's at 2 or past 2. I'm just curious. Because I think it's 2 not counting cancellation token. Provide a simple overload with no default parameters for any method with 2 or more defaulted parameters. Okay.
Yeah.
But again, we can say that this is that the kind of people who would know how to use this know what square braces mean in IntelliSense.
Flexion expression.
Yeah. Or, yeah. I don't have an opinion here. So, sounds like
I don't have a strong opinion either.
it sounds like as proposed wins by virtue of being written down.
And then the rest of the interface is straightforward. There's the bool is read-only property. There's the new slot of the indexers that provide the set functionality. There's the as tensor span variants to match the as read-only on the other, and then the mutating methods clear and fill, as well as the new slot get pinnable reference that returns the ref t instead of the ref read-only t.
Right.
And the latter two classes after the interface are basically just the concrete sealed class tensor t implementing the tensor interface. There's no additional members defined on it outside of the interface, and the non-generic class that has the comment of here's where we're exposing all the methods that mirror tensor primitives, but that we're not going to get to today.
Where are you expecting is read only from the writable tensor? It
It's
feels
the
more like
same
it would be on the.
consideration as I list of t.
Fair enough. I was like,
So
I list of t we
it's
added
the-
read only
yeah.
after, so I don't know if
No,
the read only if the I
No.
sorry I mean
that was a V1.
I read only list was added after I list, so I don't
Yeah.
know if we thought did is read only belong on the read only interface or the writable interface. I'm asking should it be on the read only interface?
It wouldn't make sense on the read-only because the read-only doesn't expose any mutating methods. So it's on the mutable one to indicate I've exposed a mutable interface for whatever reason,
Right.
generally historical reasons, but it's not actually mutable under the covers.
And it's not, yeah, because it's not actually am I immutable. It's you can't mutate through me.
Yeah.
Because you can be a read-only wrapper over a thing that somebody still has write access to. So the data can change, and it could be a reference type that's itself mutable. But okay, all right, layering seems right then. And then with these indexers, not that anyone should ever implement them explicitly, because it's new slot, they'd have to explicitly do both, right? Because once you're explicit, there's no shape matching.
Yeah, I think so.
Again, don't super care,
because yeah. I don't remember if you've got both a get and a set. If the C# rules around implicit binding allow the get version to bind to both the I read only tensor getter and the I tensor get plus setter, or if you need to explicitly implement one.
right? And I see from your shape here that it looks like
But it's a case.
this one couldn't bind because it said ref, so you had to make a clone that didn't say ref.
Right. With the refness being the consideration of what you can and can't represent in interfaces today.
Right.
We'd need something like unscoped ref to be able to be declared on interfaces and not just structs, if I remember correctly.
Okay,
And
so
then
this
the last
looks
class there is one
just like the
we're not going to
interface.
get to.
And then, well, I mean,
Yep.
the part where you made a create and a create uninitialized. These should be generic and not returning T self.
Yeah, they should be create T. Yeah, they should be returning tensor of T with
Right.
create of T. And then the commented out part I can move to a different proposal, and we can get to that in a week or two, or whenever we get back on the schedule.
So doodling these guys in, deleting all that because we didn't talk about it. Okay. And it sounds like we're done.
Yep.
I'll break this into 2 parts for precedent. Okay. And then, no, yeah. In all of your impls, which doesn't super matter, but technically speaking, you should
Yeah,
Not
because they're
redefine
not
the default.
actually consumable with the default.
Alright. Color syntax highlighting looks valid. Done.
Thank you very much.
Alrighty. Thank you. Cool. So, yeah, thanks everyone for joining us. I don't know why our calendar feed's broken again, but it is. We do have a meeting next Tuesday. Yep, it's on my calendar. We do have a meeting next Tuesday and next Thursday, because, as mentioned, we're in the aggressive part of the cycle where everybody realized they needed to put their proposals up already. And yeah, so we'll see you back here on Tuesday, where we're going to be talking about, I think, generic stuff. Not to do with generics, but just like take reds, no special topic. Yep. And cool. I've dithered enough. It's lunchtime, even though I just missed my ride. And we'll see you all on Tuesday at our same .NET time on our same .NET channel. Auf Wiedersehen.